Hi, this is Ram from Crossmind Studio. Welcome back to the second chapter of Mantaflow series. And today we are going to discuss how to shade your smoke and fire simulations with the help of volumetric shaders inside Blender and Cycles. In previous chapter we discussed the absolute basics of smoke and fire simulations, and we also talked about the very basic parameters which are available in the gas domain and the flow source for the smoke and fire. And we made a very simple smoke and fire simulation which looks something like this. It's the same file what we created in the previous chapter, and this is what we are going to take forward, and today we are going to generate one render out of this one and discuss the process of the shading with cycles. So the volumetric shading is slightly different from shading a regular 3D object. In a regular 3D object, you have one texture and you can use that texture based on the UV coordinates and place it wherever you want. But the volume shading of a smoke simulation or a fire simulation is a bit different. Because of the dynamic behavior of this smoke and fire simulation, it has a certain motion and the shader needs to follow that motion and not just to wrap around it like a texture. So just like how we use UV coordinates in a regular 3D object, we have something called attributes for the shading purpose of the smoke and fire simulations. And these attributes are generated along with the simulations what you see in this domain. And these attributes basically separate out and create different fields for smoke and the flames and the density where the heat is generated and what is the color of the smoke, and most of them you can see over here in the viewport display for the smoke domain. Over here in the physics properties, if I scroll down, I have the viewport display option, and if I enable the color mapping, you will be able to visualize most of these attributes over here. So if I select heat, you can see the heat, how far the reach of the heat is, and if I select the fuel, you can see from where the fuel is, basically the temperature over here, and also the density and few other attributes over here. So these are just for the visualization purpose but not for the rendering, but you can access these in the shading editor, and that is what we are going to discuss in a moment. But before we get to that, let's talk about what is the actual process of burning and what are these attributes. So the process of burning in real life is basically called the combustion reaction. Okay, the combustion reaction is basically very high temperature chemical reaction between a combustible material, which is basically a flammable material, in our case that is flow source, and between an oxidant, which is oxygen in the environment, and in our case you can safely assume that that is our domain which creates an environment for our smoke simulation. Okay, and combustion reaction releases heat, and that heat triggers fire, and fire into smoke. Okay, sometimes this reaction proceeds so slowly that the change in temperature is not so noticeable, and in that case you will not see the fire and only will see the smoke. But when it happens at a very fast rate, you will be able to see the flame and smoke. Okay, and that is why when we are simulating only the smoke, you will not have access to the heat parameter or the temperature parameter, but when you are simulating the fire, you will be having the access to the fire, flames, temperature and the heat parameter. So these are a few things to keep in mind, and all these terms are very common in all the 3D softwares wherever you're using smoke and fire simulations. So it's better to memorize all these and study about these, and you will be able to understand the behavior of the simulations much better if you take inspiration from the real life. Now, as we're discussing this reaction, so basically think about this. We have a fuel source, we have a domain which is like a oxidant for this chemical reaction. I mean, this is just my analogy for this, and it's not actually oxygen in 3D, but I'm just drawing parallel for that. And now as we're discussing this real life combustion reaction, now come to think of this, what are the different steps of the reaction? So we have a temperature attribute. At some temperature the reaction will trigger, and that will generate heat. Okay, so we have heat, and this heat will, if reaction proceeds at very high rate, then this will trigger fire, and these are also called flames. Okay, and this will also result in the smoke. Okay, and smoke you can measure with the density parameter, and also we have few other attributes which are velocity and smoke color. Okay, all of these reaction steps are also available in 3D for you to shade your simulation. Now to explain this in more detail, what I'll do is I'll start creating a material for this and go through it one by one. Now let's create a new material, and that will bring up a principled BSDF by default. Okay, now if I render this one, you will be able to see the surface of the material. Okay, and that is not what we want over here. Now we can see the surface because right now we are using a surface material. Over here, this is a volume information. The smoke and the fire you see is a volume inside this surface. Okay, so that is why we don't need this. And if you're coming from the introduction chapter, you will know what the volume shader is, because we made a very nice looking clouds for the final chapter, and this is the kind of same process. So over here I'll bring one principled volume and plug this one in the volume over here, and now you will see this is picking up on the density and all this volume information available within the box, within the domain system. And but there is still a long way to go, and there are still a lot of things you will need to tweak to make this more believable. This is just a basic shader. Okay, now this volume shader is all-in-one solution for all your volumetric shading needs. Okay, and previously we used to have a different volume scatter and then volume absorption, and then we used to combine that with emission and combine all these multiple nodes to make a fire and smoke simulation material shader. But now in the recent versions we have this much better, much more convenient all-in-one node which is called principled volume, and you can access all these properties of the volume within one node, and it's much more organized and much easier to access. Okay, so let's go through this one by one. Now this is the your main shader. Now along with this shader, as we were discussing, we would need attributes, and as you can see, these are some of the attributes which are already being used by default over here. Okay, and anywhere you can click and type, these are attribute sockets. Okay, temperature attribute, density, and over here we have color, where we can use the color attribute as well. We can also bring external node which are attribute nodes and type on attributes over here. Okay, there is one more node over here which is called volume info, and this is also kind of a similar node, but basically what this does is this gives you four major attributes which are related to the volume. Okay, so you can either bring one attribute node and type here manually, or you can bring a volume info node and access all these four nodes from here. But this is not the complete list over here. Other than this, we have one heat attribute and one is the temperature attribute, but those two are experimental attributes, and those are, you can access it, but those are like a quite experimental. Okay, so let's go through these parameters one by one. And the first input over here is the color input, and as the name suggests, this input is for the color information which you will see over here. So if I change this color, basically this will change the color of the smoke over here, and this will sound simple, but this is not the only use for this. Okay, a much correct way to use this is to access the color information which is actually there in the simulation with the attribute called color. Okay, and we will get to this part later in a moment, but basically what you can do is whatever color information is available on the flow source, if I select the flow source over here and go to the physics properties, you will see the smoke color over here, and you can animate this value, and that will create a smoke of multiple colors, and this should happen before the simulation. Okay, and once you have the simulation, you can access all those colors in this domain over here and plug that into here. Okay, and what that will do is, instead of creating a flat color, you can actually access the color information which is there in the simulation. So like I said, I will explain this with a better example in a moment. And second is the color attribute. The color attribute is basically based on what you want to color your simulation, basically the smoke. If I type color over here, which is one of the attribute, so basically this will pick up the color from the actual flow source over here. Okay, right now our simulation is baked with a gray color, that is why we can't see much happening over here, but basically this will pick up the color from the simulation. And if I type density over here, then this will shade my simulation based on the values of the density. Wherever the density is more, my smoke will look much more brighter. Wherever density is less, smoke will look much darker. Okay, now you will see, you might think this is a very good solution, but it might not be ideal for all the situations. Okay, so and maybe sometimes if it's a too dense smoke, then that might create black patches because of the negative value or the darker value of the density. And that you will see if you enable the environment over here. If I increase the density more, you see these darker colors. These are because of the density values. So but still you can use this in some cases. There is no right or wrong way about this. This is all experimental. Okay, now I can type some other attribute over here as well, like a heat or something. But like I said, the best attribute to use over here, and which is by default this is empty, but the most useful one over here is the color attribute. If you don't have any color information in the simulation, you can leave this blank. That is safe to assume. Okay, the third one over here is the density. Okay, and the density is pretty straightforward. If you reduce this one, you're on the zero density, basically your smoke have no density, that's why you won't be able to see anything. But the more you increase it, the much more dense your smoke will become. Okay, and if you make it around 5 or something, then you will see much more prominent shape of the simulation. Okay, but still this doesn't look a very correct representation of what we see in the viewport, but we'll get to that in a moment. Okay, so I'll just make the smoke a slightly colorful just for the fun for now. So this is density, and the density attribute is basically based on what the density will work. If you make it blank, then basically this will fill up the entire box with the volume. So density should always go over here. And yeah, okay, I'll just make it back to white. Anisotropy is basically will decide how much a light will scatter inside the volume, either in the front or in the back. Okay, now to explain this example much more clearly, what I'll do is I'll enable the environment and over here I'll bring some other HDR where you can see this with a much clear light source in the background. So I have this studio HDR over here. I'll just disable these hue saturation nodes and gamma node for now. So this studio EXR, basically we have a pretty strong light source over here. Okay, now if I go to the object material, now I'll increase the density just to explain this example. So basically what happens is, if you make this anisotropy parameter, if you increase it in the positive value, the light will scatter and create a rim. Okay, and this light is scattering in the back side. Okay, but if you make it a negative value, then in that case whatever light source is in the front of the smoke simulation, the smoke, then that will scatter more in the front of the area of the smoke. Now we have this light source over here, and if I make this, if I start increasing this number, you will be able to see a very clear rim that is forming around. Let me just increase the density even further. And okay, for now I'll just use a density attribute, but this is just to explain this example. So you can see it feels like the light is observed and scattered from the back side of the smoke shader. Okay, and if you decrease this number and make it a negative value, then you will be able to see more of the front because the light is scattering from the front. And this is a very useful thing if you are, when you're shading in a specific situation, like you have one smoke simulation or the explosion happening against the sun source or a very strong light source and you want to form some nice rim around it, so you can control it with the anisotropy over here. And if you make it all the way 1, then you will be able to see a clear visible light source over here. Okay, now think of this like a glossiness parameter, the roughness parameter. When the surface is fully glossy, then you will be able to see the clear reflection of the lights and the things around it. But the more you scatter and the more the roughness is increased, then that thing blurs out. Okay, similarly, if I reduce this parameter, then that light source will scatter over here in the back of the smoke and create this nice rim. Now let's go back to our original state of the file. I'll load sunrise.exr. Yeah, there you go. And I'll enable my scene lights. So that is anisotropy parameter. Okay, so I'll make it 0 for now. Now next is absorption color, and this we will discuss later. So let's talk about emission strength. And if I increase this, you will see basically this will add emission to our wherever the presence of the simulation is. Now this have a lot of use, and basically what you can do is, instead of using just the flat value of emission, these values you can drive with the help of attribute. If you plug in some density or flame attribute over here, this emission will take the shape of it. And now let me just explain this with a better example. I'll make the density 0. Now you will see if I make the density 0, this basically doesn't have any information for emission to follow. Okay, and now what I'll do is I'll plug in a color over here from the attribute. Sorry, I'll use a factor, and over here if I type density, now you will be able to see the emission is basically forming based on the density of the simulation, and you can increase the strength of it, and this is working like a emission shader. Okay, now there is much more you can do with this. If you bring some more math node over here, you can control it. Like if I bring one power node over here, I can control the appearance of this and make it look like some flames. Okay, but these are not true flames, these are actually density forming around using the emission shader. But you can use this as well to add some emission inside your simulation other than the black body intensity which is available over here. Now black body intensity, sorry, we should use this in emission strength. Yeah, my bad. So emission color is basically what color you want this emission shader to look like, and black body intensity is basically your flames. If I use any higher value, like any value, that will decide the strength of the flames visible over here. Now let me explain this with a better example. Let's say if we have the density of 1 in the simulation, and let's decrease the emission strength back to 0. So we have the density over here, we basically have the smoke, and let's increase this. Now let's talk about how you can control all these attributes, and basically instead of a flat value in the density or the emission, you can use the attribute and form much nicer visual for that. Okay, so right now we have a flat value in density. Okay, now just like how we use a texture in the input, we can use the attributes as well. Now let's see if I use density over here instead of a value, flat value, any number over here. Now you will see a much better representation of the actual simulation over here, okay, which is visible in the viewport. And now I can tweak this in so many ways instead of using just a flat number, and this is much more artistic control. So if I bring one math node over here and add power to this, okay, the power node is basically it's a much complex mathematical function, but basically oversimplifying this, if you increase the power, this will work exponentially, and wherever the values are higher, it will strengthen them more, and wherever the values are weaker, you will see them getting weaker. Okay, so over here I'll increase this to 1.5 and make a duplicate of this and change the mod to multiply. Now over here we have some better form of the smoke. So let's decrease the power and make this a slightly darker smoke. Okay, let's make it 10.7 and just work around until you find a better shape for the smoke. Basically it should look like whatever you see on the screen in the viewport. Okay, all right, so we have the smoke over here, and we have the black body intensity forming the flames. Now if I make it 20, we have the flames over here. And let's add some anisotropy to this one. All right, now this looks interesting, and we have basically the smoke and the fire. Now something feels missing over here, and that is basically whenever you see a smoke simulation or the fire simulation in the real life, from wherever the heat is generated, and that doesn't disappear abruptly. As you can see over here, we can see the flames forming till over here, but it seems like none of that heat is affecting the color over here or reaching some broken flames should be present over here as well. Okay, now even though this is accurate, but you can still exaggerate things in the shading process with the attribute. Now what I can do is, let me just disconnect this socket so you can see what emission is doing over here. Let me just rebuild this node for your for clarifying this again. If I plug this one in emission strength, so basically emission strength is using the density. Wherever the density is much higher, you will see much more emission happening. Wherever is density is weaker, you will see basically the transparent values. Okay, and now let's copy this power parameter over here, and let's increase this until you see some subtle flame looking thing forming around here. Okay, and I'll clarify this again, these are not actually flames, but these are visually, these look like flames, but this is just a emission shader working on the density. Okay, now let's make a duplicate of multiply node, and now what I'll do is add some more strength to this. Just like how we black body, we see over here much more energy we have. I can add one gamma node and make it look like this. All right, now if I enable the smoke, you will be able to see some of that, the emission shader working over here. Okay, so without this, we had very dull looking smoke, which basically doesn't have any information of the heat. Now if I plug this into emission strength, you will see this looks much better, much more realistic, and I can control this, how much I want this heat to be, these flames to be present inside the smoke with these parameters. And this is not the only attribute you can use over here. Instead of density, you can also use heat over here. Okay, and actually I prefer using heat, and this looks much more believable. Okay, now to clarify this one, I'll show you a better example. What is the difference between heat and density? At the first glance, if I type density over here, these two look pretty much the same. Okay, I mean, you have some flames going on, forming like this. But if I make a duplicate of everything and plug this over here and change this to heat. Okay, now let's bring one mix RGB node and plug this over here, and now we have one based on the density and one network based on the heat. Now see what happens if I make this towards the density. This is the density working, factor 0, and if I increase this, there is a very subtle difference. Basically what is happening is, when we shade it using density, that works everywhere wherever the smoke is more dense, but that doesn't generate from where the heat is triggered. Okay, but if I make it heat, then you will see the more power over here and less power over here. Okay, and let me just make the black body intensity to 0. Now you will be able to see the difference much more clearly. This is based on the density and this is based on the heat. Okay, I hope you can see the difference, and to clarify this, what I'll do is I'll exaggerate it even further. This one is density and this one is heat. Okay, this is density and this is heat. Okay, now in the heat there is more power over here. This is much, because the heat is generated from our flow source, and over here it will have much stronger value, and that will fade away as it reaches the top of the simulation. But the density, because this is a density attribute, this is not coming from the emissions, I mean the heat of, or the temperature. This is just the fog, which is the smoke which is in the simulation. So that is why you will see some you will not see some dramatic change over here. Okay, so this is a very subtle difference, and I hope you can notice it. Yeah, and I'll just delete this one and plug the heat over let's just use density for now. So black body intensity, basically that works based on the temperature, and if I disable the emission as well, you will be able to see this is forming the flames. Okay, black body intensity. All right, and if you want these emission flames to look much more natural like black body intensity over here, you can also bring one black body node and plug that into color. Okay, now you will see this black body node basically gives you much more accurate colors based on the temperature. Okay, you can see the temperature parameter over here. So instead of using an orange or yellow color over here, you can insert black body, and this will give you so much better visual based on the temperature. Okay, and the next parameter is the black body tint, and this basically is whatever the flames are formed with this black body intensity parameter, you can use a nice tint for that and make it look stylized visuals. Okay, and the next one is the temperature, and this will basically you can use any number, and based on that temperature number your flame will either brighten up or get weaker. This is just not about the brightness of the flames, this will also change the color of the flames and based on that temperature. Okay, if I make it a weaker number, then you will see other than increasing the brightness of the flame, this is a color based on the temperature. And if I make it some really strong over here, like maybe 2000, then it's much brighter and the color is more yellowish. Okay, then we have a temperature attribute, and this is basically what is the attribute used for the black body intensity over here. Now there is sometimes a confusion that what is the difference between the temperature and the flame attribute. So I'll just clarify that with one example over here. So let me just plug that into emission, because this is a much easier way to visually show you the difference between these. So let's use temperature in this one, and let's make a duplicate of this, and let's use flame in this one. Okay, so basically what is happening over here is if I use the flame attribute, this is working on the density of the flame. Wherever the flame is the density is much more higher, you can see the thicker flames. Wherever the density is less for the flames, you can see a very mild very subtle looking hint for that. Okay, and that is the only difference. Okay, and if you use the temperature, this is basically the energy, which is the temperature that is generated when the simulation happens. Okay, in some cases you can use the temperature, and over here this is used for the black body intensity, but to form the much nicer flames you can use the flame attribute over here. So yeah, that's about it for all these parameters. So we basically have one density that is going on over here, and then we can use emission strength to add some artificial flames. Then we have emission basically the black body color which we used for the emissions color, and we have flames which are generated over here with the black body intensity. So this is how you can basically shade your smoke and fire simulation. But this is not a perfect example, and this is just to show you how all of these work. Now let's go to the final file and create one perfect shader for our simulation. Okay, now let's go to the final file over here, and this one is on the 256 resolution. So over here you can see this simulation is on 256 resolution with the upraise factor of 2. This is what I used for the final render. Okay, and this file gets much heavier. It's okay if you want to try it out on much lighter version like 128 or 180 resolution, just like how you see in the previous example that was 180 resolution. Okay, we have one basically material output over here. I have a smoke domain material, and I'll start building up the final shader for this one. So I'll just bring one shader and a principled volume and plug this one over here. Okay, and enable my rendering. All right, Now you see we have basically a nice smoke going on over here. So before I start shading this one, let me show you my HDR which I'm using, because some of you might have concern about that. So it's a very basic HDR setup. This is sunrise.exr, which comes from the very default folder of the Blender Foundation, Blender 2.82, data file, Studio Lights, Word. You can also see this HDR from over here. This is the sunrise.exr, which you also use in the look dev mode. Okay, the only differences over here, I increased the saturation a bit and I also increased the gamma strength, and now I'm using this on the strength of 2. Okay, so this is a much stronger light source and setup around here. Okay, then I have few lights which I'll show you later. Now let's tweak this smoke over here. Okay, so I'll bring one attribute and type in density over here, and I'll use this factor to adjust the value of the density. I'll bring one math node and change this to power, and I'll make it around 1, so I can see a much clear forms of the frames and the smoke wherever the density is forming some curls. We can always power this up with another node and add multiply to that, and I can ramp this up by around maybe 20 or something. Alright, this looks good. Now I can add some brightness contrast to this one, maybe make it 1, and I can change the color of the smoke to something cooler. Or what I can do is I can basically bring one color amp over here and plug that one into this one and this multiply value to the color ramp, and give this one slightly cooler color. I'm going to tweak this these values around. This looks too dense. I can make this 1.2 and this around 20 and increase the contrast by around 2. Okay, and now I have much more clear definition of the actual simulation. So this looks better. Just make sure that you don't add so much density that it will start showing up these voxels. Okay, now I've seen some of you, like I made this mistake myself, that just to make the smoke look much more thicker, you might end up using a lot of density value. Okay, like maybe around 150 or something. Okay, now this looks good, but this simulation is made of voxels. These voxels have the information of the volume. Now these volumes are inside the voxels, and after a certain point when you push the density too much, instead of the true information like whatever you see over here, okay, now technically whatever you see over here, this is the smoke which is generated. Okay, but whatever you don't see over here, that information is still there in the voxel. However minor that information is, that is still there. Okay, so maybe it's 0.01 smoke which exists over here which you can't see. Okay, but when you increase the this density too much, now this will fill up, this will empower those unseen voxels as well, and what will happen is it will basically make it a solid voxel, and after that point you will end up making your simulation look like this. This will have grid lines and voxel lines everywhere, and this is not actually the right. So if you really want to make some thick smoke, then you should add more smoke to your simulation, not in the shader. I mean, you should add more smoke which is emitted from the volume, and maybe add more emitter sources and run the simulation for much more frames. And when technically there is more smoke, that is when it's going to look much more natural and dense smoke. Okay, now this has limitation, so this is not the right way to make your smoke look thick. So just keep that in mind. And also, as I mentioned over here, you can leave it blank if you want and adjust your visual of the smoke from over here, like how darker or brighter you want this to look like. But one of the quick way, this is just an experimental trick. For some cases this works, and especially when the background is darker. So if I type density over here, my visual looks much more better. Okay, because the true density information is overlaid on top of the color. Now if I make it 0.9 and 50 and 1, now you will be able to see this visual looks much more better. But like I mentioned previously, the problem over here would be, in case you start seeing these dark patches, then you should ignore this and just adjust it from here. Okay, but let's keep it this way for now. Now we will work on our black body intensity. Basically, let's add some flames to this, okay? And that is pretty simple. You just need to increase this value, but this looks way too purple, and I'm going to make it much more subtle, something which has slight hint of blue but not too blue. All right, and maybe I can crank this up a bit more, the black body intensity. So now we are going to add some heat over here, okay? And like the process of this we already discussed. I'm going to enable the emission strength and use heat attribute over here, and I'll also bring up one separate node for the black body color, which I want to use for emission color. Now we have the presence of the heat over here, okay? Now we are going to tweak that. We'll make a duplicate of this power node and make it around 2.5, okay? Now let me just disable this density for now. Now I'll add one more multiply node and make it around 12.5 or something. And I can also add one gamma node just to make it look much more powerful, something like this, okay? Now let's enable our density again. There you go. So now we have presence of a slight hint of flames and the color of the flames going on over here, okay? And you can adjust that if you want this to look much more dramatic. You can add more value to this, decrease this number. So that is totally up to your taste, okay? The next one is the anisotropy, and I'm going to use a very subtle number for this one, 0.5, okay? What will happen is whenever I have a strong light source in the back of the smoke, I will see some light scattering inside the smoke. This will react much better to the light sources. So that's about it. This is the final shader which I've used for the render which you've seen in the trailer, and it's simpler, but it definitely took me much more time than this to figure this out, to find the perfect field. So what I do is, whenever I have one network, so let's say if I make a duplicate of this one, and so when I have one network, then for the density and all, I usually make one duplicate of that. Then I start experimenting that, like maybe you can mute few nodes and see what combination works better. And you can also play around with the different mods which are available in the math node. And also you can try out a few different colors. Let's say if I wanted to make some really toxic looking thing, and also I can enable emission color, and I can also add one hue saturation over here as well. Sorry about that. This goes into emission strength, and this goes into emission color, and over here I can add some hue saturation. So this way you can completely change the look of your simulation and make it however you want this, okay? So these are just very basic examples, and this one is the final shader which I've used. So yeah, that's about it. And I rendered this one on around 180 resolution, and the one frame took me around 7 to 8 minutes. Now when you have this simulation, and it's always there is so much work that goes into this, so if you are doing this for your personal project, it's always fun to also render this out from different views, and play around with the different lights. You can take a few close-up shots. So as you've seen some of the close-up shots happening in the trailer, so I used the same simulation and basically generated some close-ups, okay? Just enjoy your first simulation and shade it, play around with this. And here is the final render which I've used in the trailer. So this is the final render, and these are some of the close-ups. Now I wanted to explain a few more things before we conclude this chapter, and that is about how you can use the color attribute, and how you can also use the factors of the density to combine two colors, okay? So for that I will bring up a different file. Now here's another simulation which I've created just for the purpose of explaining how you can use a color attribute. So over here, if I select the flow sources, what is happening is I have multiple keys set up of the smoke color. Just like how you set key for any modifier parameters, you can simply press I on this one and change the color. So it's a very simple process, and I'm sure you're familiar with this one. So as I scroll in the timeline, you will be able to see multiple color introduced at the different frames. Those colors basically mix up over here and produce vivid looking simulation. So this is not what you can do with the color ramps in the shading. Okay, like in the color ramps, you have a color which is basically working like an overlay. Okay, that doesn't follows the physics of the simulation. But over here, you can see as the new color is introduced, that emits from here and that also fades away and mixes up with the other colors. So this is what we are going to use for the render purpose. So here's the render setup for this one. So what is happening over here is, if I enable the render without these two inputs, I'll disable the color input and I'll disable this attribute. Okay, without this, what will happen is it will just pick up a flat color over here. Over here, I have one attribute which is basically plugged inside the color over here. And what happens is this color attribute will pick up color data from the simulation and apply this over here. Okay, and then I added hue saturation to add some more vibrance to that. Now one thing to keep in mind is you need to set keys for the colors in the simulation before you bake it, because the change of the color will be calculated in the simulation, so you can't change that later and expect that to work over here. So you need to keep that in mind. So always set the colors or the color keys before you bake the simulation. And then also I can call the color attribute over here as well. Now you will see smoke is using the color attribute. This looks much more interesting. Okay, I will show you the final render, what it looks like. So here's the final render, what you see, and this is how you can use the color attribute. Okay, and now here's another example I wanted to discuss with you, the last one. And this is basically about how you can use attributes as a factor, just like how you use textures to combine multiple colors. Okay, over here I have a different node. I'll just explain this very quickly. So let's say if I bring one attribute over here and call this density, okay, and plug this one into the emission strength. Now let's bring one black body and plug that one into emission color. Let's bring one math node and make it to power, something like this. All right, and you can also multiply this one. So I have this black body color affecting the emission. Okay, now I'll make another version of this one and I'll tweak this color with the hue saturation and make it something like a cool color. Okay, now what if I want to add these two colors together? I mean combine these two colors together, but not with just some texture, but with the attribute. Okay, now that is the interesting thing about the attributes. Now I can combine these two colors, but that will still follow the simulation's animation. Now if I go over here and bring one mix RGB, so in lower input I'll add the blue color and in the upper I'll add the warm color. Now I'll make a duplicate of density and plug that into factor. Now you will see wherever the density is much higher, I can see the first input, the second input, and wherever the density is much lower, I can see the first input. And this is a much more interesting example how you can use these as a factors. And after that you can if you want to control it further, you can always bring another node, which is it should be over here. So wherever the values are less than this number, I will see the first color. Wherever the values are more than this number, I will see the second color. So this is what I've used in this over here, but there is a slightly more detailed work into this. I mean it's not so detailed, but so in the factor, just I explained, I have one density and I have this value less than and more than controlling the density, which is going into the factor. Okay, so I have one density factor affecting these two colors, I mean combining these two colors, and then I have one gradient. This is a linear gradient which is going basically from bottom to top. Now I combined these two with another mix node, and then I played around with the different settings of the mods, and I found this one better. So that is what I'm using over here. Okay, so I hope this gives you some idea how you can combine with the attributes, and this works just like how you combine two nodes with the texture inputs. Okay, so yeah, that's about it for today, and this was a lot, and but I would suggest you guys to just play around with these values, and not just put the numbers which I have used in the tutorial. So that will not be fun. I mean, you should make a totally new look based on your observations, and play around with these values. Nothing can go wrong with a computer simulation. Okay, so just try out different looks for your simulation, play around with the colors, density values, however you want, and don't hesitate to play around with this. Okay, so I hope to see what you guys make with this simulation and the shading chapter, and I would love to see the results and your simulations. Do tag me on Instagram with Crossmind and share your results. I would love to see what you guys create with this one. Okay, so our next chapter is going to be about how you can practically add smoke or fire simulation to a 3D object and within a 3D scene, and do a production ready render. Okay, instead of making some raw attempt in a blank file, we will actually make a smoke or fire simulation, however basic it's going to be, but it will be within a 3D scene. Okay, so I will see you in the next chapter, and hope this was useful and you guys learned something. Do let me know in the comment section, and also if you guys come up with a better solution or some exciting new tricks, don't forget to share it with me. So I will see you guys around in the next chapter. Good luck, have a great day, goodbye.